Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners. Welcome to today's Natural Sciences lesson. My name is Mr. Sianda Madlala, and this lesson is proudly brought to you by the Gauteng Department of Education in conjunction with Pagama Research and Development. What are we going to do today? Today we'll be focusing on the topic resistance, right? Which is our part of what? Electricity. We'll be talking more about resistance and specifically on the uses of resistors and factors that affect resistance. So now remember that this topic is also found under the main knowledge area, which is energy and change for our term 3, and it contributes about 80 marks in your exam. So we better focus, right? So now, whilst you're still thinking about this topic, let's move on to lesson objectives. Let's see what we need to achieve by the end of this lesson. So by the end of this lesson, you should be able to explain that conductors heat up when current passes through them. You should be in a position where you can tell us that conductors do heat up when current passes through them. Not only that, you should be able to explain that some energy is lost or wasted as conductors heat up, right? You need to be in a position where you can be able to identify and also explain that energy is lost or wasted when conductors heat up. Not only that, you should be able to describe what a resistor is. After describing what a resistor is, you need to be able to describe how it works. You need to tell us how a resistor works. Moving on, you need to be able to tell us or list the uses of resistors, right? You need to tell us the uses of resistors. And also, you need to be able to list the 4 factors that affect resistance in a circuit, in an electrical circuit. And also, you need to discuss those 4 factors that affect resistance in a circuit. And all of this information is found under the CAPS document on page 73. So now, let's move on and check what we have done in the previous grades and the same grade prior to today's lesson, right? So, in grade 6 and grade 5, we have done electric cells, right? And in grade 6, we've also introduced mains electricity. Not only that, in grade 7, we further talked about supply systems, right? Not only that, we talked about the national electricity, right? And electric cells, yes, in grade 6. And also we have done what? Energy transfer in electrical systems during our grade 8. So now, after having this knowledge, right, in terms of what we need to achieve by the end of lesson, and also what we know so far, right, I want us to test ourselves using this baseline activity. For number one is asking you what is a resistor. So you need to tell us what a resistor is because we have done it in grade 8, right? So now, number 2, it says, what is the unit of measurement for resistance? You need to tell us the unit of measurement for resistance. And number 3, you need to tell us what is a rheostat. Then number 5, you need to tell us why do conductors heat up in an electric circuit. So it's 4 questions and you deserve 4 minutes to answer each question. So we'll meet again after 4 minutes. Welcome back, grade 9s. Now, if you have any questions or comments during this lesson, you can WhatsApp us on our WhatsApp interactive number, which is 079 578 2908. We are waiting for those questions and comments. For now, let's mark this baseline activity. So now, number one is saying, what is a resistor? So what is a resistor, guys? A resistor is a component in an electric circuit that opposes the flow of current through it, right? It has the ability to oppose the flow of current in an electrical circuit. Then you give yourself a tick, right? Then number two, what is the unit of measurement for resistance? And resistance is measured in ohms, right? And here's a symbol for ohms. And also, number three is saying, what is a rheostat? So what is a rheostat? We know a rheostat as a form of a resistor, right? But what is really a rheostat? A rheostat is what? It is a resistor in which resistance can be manually changed, right? It can be manually changed. Then number four, why do conductors heat up in an electric circuit? This is the answer, right? It is because of the resistance of the wires, which opposes the flow of electrons, and the electrons bump into atoms outside the wire, losing some of their kinetic energy as heat. So now, I know it's a lot to chunk in, right? So now I'm going to give you a minute to copy down the corrections. Then after that, you can continue with our lesson. Right. I now hope that you had enough time to copy down the corrections, right? So now let's look at the important terms before we continue with our lesson. The first terminology that we have there is conductor, right? A conductor is a substance or a component that allows a flow of electrical charge through it, right? It allows electricity to pass through it. The second one is resistance, right? What is resistance? Resistance is an action, right? So resistance is an opposition to the movement of charge through a substance, right? So now, we also have resistor. What is a resistor now? We said a resistor is a component that opposes the flow of electric charge or current, right? It opposes the flow of electric charge. We also have rheostat. And we said that a rheostat is a resistor in which the resistance can be manually changed, and a rheostat is also called a variable resistor. It is changeable, right? And also ohm. What is ohm? Ohm is the unit of measurement for resistance. We also have ammeter, and an ammeter is an instrument that is used for measuring electric current, and it is measured in amperes, right? It is the symbol A. We also have what? Ohm meter, right? So now look at the differences here. It is ammeter and it is ohm meter, right? The ohm meter now is a component that is used to measure resistance. So now, I hope these terminologies dwell in your minds, right? So that you're able to understand going forward. Now, to today's main meal, we're talking about resistance. But before we get into to resistance, we need to highlight that a conductor is a substance that allows the flow of electric charge, right? It allows the electricity to pass through. And we have examples of conductors such as silver, gold, steel, and aluminium, right? All those substances, they allow electricity easily to pass through, right? So now, what is resistance? Resistance is what? Opposing the flow of current now, right? That's why we need to understand the statement first, right? That the resistors are working against what? Conductors. So now, resistance is the opposition to the flow of current. And what offers this resistance? It is the resistance, right? A resistor, which is a component that opposes the flow of current. So now, I want you to note the difference as we move on, right? Resistance is the action that is being done by the resistor, right? A resistor offers resistance to oppose the flow of current along a conductor. Are we together? So now, let's remind ourselves, what is the symbol for a resistor in an electric circuit, right? We have several symbols here, right? That's some that you're going to come across in the later stages, right? So now we have fixed value, we have rheostats, we have potentiometer, we have taped, we have thermistor, and we have photoresistors. Those are all examples of resistors. But for our grade specifically, I want us to focus on these two, right? The fixed value ones, right? These are the symbols that you need to focus on for resistors in an electric circuit. Moving on. So now, how does resistance happen, right? We said that a resistor tries to prevent the flow of electric charge. I like this word here. Tries to prevent, right? So now, it controls the flow of current. It can completely stop the flow of current, and also it can minimize it, right? Hence, we say it tries to prevent the flow of electric charge. And a resistor is placed in a circuit to control current or to provide what? Useful energy transfer. What do we mean when it says it is used, when we say it is used to provide useful energy transfer? Now let's think of a kettle, right? The one that you use to boil water, right? It has an element there that serves as a resistor. You have electrons coming in from the cord that is connected to the wall socket, right? The electrons or electrical charge is coming in, and it finds that resistor as the cord. That coil now transfers that electrical energy into heat energy so that you can be able to boil water. So a resistor is placed to control current or to provide what? Useful energy transfer. And we have examples of resistors such as light bulbs, rheostats, motors, and elements of heater, kettle, or electric oven. They all serve what? The purpose of opposing the flow of current, such as light bulbs as well, that we're going to talk about again in this slide, right? What happens here? It uses up that energy. It opposes the flow of current by using up that energy and converts it into a different energy, right? So now, let's move on. This is how resistance works, right? You have now electrical charge moving to that direction, right? This is electrical charge or current, right? It is moving towards that direction. Remember, resistance, it is serving the purpose of what? Of opposing the flow of current. Hence, you see the hand there that says resistance. So electric charge moving towards that direction, whereas the resistance moves in the opposite direction to oppose the flow of current. Are we together? So as we can see here, it is blocking the electrons from flowing to the other side, right? So what happens here? It tries to oppose the flow of current. So now, we also have rheostats, right? And we said that a rheostat is a resistor in which the resistance can be manually changed, right? So now resistance in an electric circuit opposes the passage of electrons, and it is measured in ohms, right? It is measured in the unit ohms, and we use a tool which is called what? An ohm meter to measure resistance. We have a tool such as this, right? This is an example of an ohm meter. As you can see here, the unit of measurement is ohms. So if you were to measure resistance, it would give you a reading here to say it is 100 ohms or so on, right? Depending on the resistance. But now the fact of the matter is that the unit of measurement here is ohms, and it has such a symbol. Moving on, uses of resistors. Why do we use resistors, right? Why are they so important? Remember that resistance in an electric circuit opposes the passage of electrons, right? So why are these resistors so important? So they are important so that they can be able to provide useful energy transfers, right? Think of light, think of a kettle, right? You have electrical energy entering the component as light, or the heater, or the kettle, right? So now, the resistor there does what? It transfers the energy from that electrical energy either to light energy, to heat energy, to sound energy, or whatever form of energy. So resistors serve a purpose of what? Providing useful energy transfers. Are we together? I want us now to look at something here, right? We have a link here, which is from PHET simulations. PHET simulations is spelled like this, P-H-E-T simulations, right? You can use this website to work out on circuits and test everything that you need to know about circuits. It is very interesting, right? So I want us now to look at this so that we can be able to look at forms of resistors and their uses. So now let's log in and check under lab, right? You check under lab, and here is our lab. It has different components, right? As you can see, it has wires, batteries, light bulb, resistors, switch, and so on, right? So now let's construct a circuit. Like firstly, going to put a wire here, right? Then we put another wire here so that we construct a simple circuit, right? Remember, a circuit needs to have a source of what? Electricity. We're going to put another wire here as well, right? Then we connect a resistor. Remember, we said that light bulbs as well are resistors. So we're going to put a light bulb here as one of the resistors, right? So let's see what happens here. We connect another wire again, right? Then we connect another one here so that we can complete our circuit, right? Another wire here. Remember that a circuit needs what? A switch. We're going to put a switch here. So now the switch is open, right? There is no flow of current. But now I want us to notice, as there is flow of current, what is happening to the resistor? What is happening to the whole circuit as well? So now, as we switch on our switch, right, what happens now? The light bulb becomes on, right? It is lit. So what is happening here? There is flow of current, right? There is flow of current, and in this case, it's convectional current, right? It is moving from the negative terminal of the cell to the positive terminal of the cell. So it is, as it is moving all around here, notice what happens to the light bulb. The light bulb is lit, right? So now there's that energy transfer now. All this electrical energy that flows here, it is transferred into heat and light energy, right? This resistor here serves to do what? To transfer this energy from that electrical energy into heat and light energy. So now, I want us to also add a resistor, right? And note the change here. So now let's cut this wire here. First of all, let's switch off the switch. Let's cut this wire here. Now let's look for a resistor, right? Let's look for a resistor. Here is one here, right? We're going to connect this resistor here. Let's look for another wire to connect it. Right. Yes, right? So now we have a resistor connected here. So what is going to happen now? Look, when we switch off, there's no flow of electricity, right? It has opposed now what? The flow of electricity. There is no what? Energy moving in a circuit. Now, do we get this? I hope so, right? Let's go back to our lesson to learn more about resistance. Now, moving on. Now let's talk about what happens inside an electric kettle, right? As an example, we have given you what? An electric element, right? Of a kettle. We said that that metal coil inside the kettle serves as a resistor. It also transfers that electrical energy into another form of energy, which is heat, right? So when the electrons move through the resistor, they release a lot of energy in overcoming the resistance. As I told you that the resistors are fighting what? Against the flow of electricity. So there's what? There's high energy that is used in overcoming the resistance. So as the electrons are flowing in, right, there's high energy released in overcoming the resistance, and the resistor as well is putting more resistance. As a result, what happens? That metal coil starts to heat up. As it heats up, right, that energy now, that electrical energy is converted into heat energy so that you can be able to boil the water, right? The energy is transferred to the water in the form of heat. So let's look inside this kettle. Yes, this kettle is connected to a cord, and the cord is connected to a wall socket where it receives the energy, where it receives the electricity, right? As the electricity flows now into the kettle, right, what happens? It comes across this element which serves as a resistor. This element offers resistance. It opposes now the flow of current coming from that cord. What happens now? It starts to heat up. As it heats up, its intention is to boil water, right? The water boils to a point where now there is too much heat. When there is too much heat or the water has reached its boiling point, what happens to the kettle? Right? The kettle goes off, right? Now there's too much resistance. Are we getting this? So now, we also have an example here again, which is resistance in an incandescent light bulb, the one that you are familiar with, right? The same happens here. Energy is transferred from electrical energy into another form of energy. So inside that incandescent light bulb, there is a thin coiled wire in the glass bulb called the what? The filament, right? The filament is made up of what? Of tungsten wire, which has high resistance. So that tungsten wire is the one that brings about what? Resistance, or the opposition of the flow of current. What really happens here? When the electrons move through the filament, they experience high resistance, right? When they move through that filament, they experience high resistance because of the tungsten wire that it is made up of. And this means what? It means that the energy is going to be transferred, and it's going to produce what? Heat and light as a result. Here is an example of what? An incandescent light bulb that we know of, right? Also, it is part of what? A circuit, right? It is connected in conductors or wires to transfer what? Or to transport this electrical energy into it. So what happens? Here is the filament here, right? That thin wire, which is made up of tungsten wire. That filament here offers resistance now to the electric flow. It opposes the electric flow. What happens now? As a result, the energy is transferred, right? It is transferred into light and heat. But now, when you're talking about a light bulb, what are we trying to get here? We're trying to get light, right? Heat is just a byproduct of the process, right? So it is transferred into light and heat because of the resistor in this light bulb. So the electric flow now is being opposed by this tungsten wire or the filament. So now, we have done enough talking, right? Here is an activity. I want us to take 2 minutes and test ourselves quickly using this activity. Number 1 says, true or false? The element in an electric kettle is a resistor. Then number 2, what is the wasted energy output in a light bulb? 2 minutes. Welcome back, grade 9s. We are still waiting for those questions or answers, right? You can even send us your work for these classworks, right? So now the number is 079 578 2908. So now let's do the solutions for our activity 1. I know that number 1 was a bargain, right? I hope so. Number 1 says true or false, the element in an electric kettle is a resistor, right? What is the answer? The answer is true, right? The element in that kettle, it is a resistor. It transfers the energy from one form to another, right? From electrical energy into heat energy. So you give yourself a tick. Number 2, it says now, what is the wasted energy output in a light bulb? That one can be tricky, right? But before we go to this activity, I explained it to you. And the wasted energy output is what? It is heat, right? As I said that from a light bulb, we're not looking for heat. We're looking for light. But now, heat is also a byproduct, right? Of what? Of the process. Now, let's move on to activity 2, right? Activity 2, it is quite long, right? It has 5 questions. So I'm going to give you 5 minutes for it. But firstly, let's go to the questions together. It says on number 1, what is the difference between a rheostat and a resistor? Number 2, what material is the resistor in a bulb made of? Then number 3, what causes resistance in a circuit? Number 4, give us 3 examples of good conductors of electricity. Then number 5, what are materials that do not conduct electricity called? Then you give us examples. Let's meet again after 5 minutes. Welcome back, grade 9 nerds. So now, let's move on to solutions, right? So now, number one was saying, what is the difference between a rheostat and a resistor? What is the difference between the two? A rheostat is what? Is a component in an electric circuit which has what? A resistance that can be changed, right? So it is a form of a resistor, but that the difference is that the resistance can be manually changed. And a resistor is simply a component in an electrical circuit that opposes the flow of current. Number two, it says what material is the resistor in a bulb made up of? It is made up of what? Tungsten wire, right? Don't forget to mark your work, right? It is made up of tungsten wire. Number three, what causes resistance in a circuit, right? It is what? It is the resistors such as light bulbs, buzzers, motors, kettle element, heaters, and so on, right? All the forms of resistors. Then number four, give three examples of good conductors of electricity. The ones that allow electricity to pass through, right? Which are your gold, silver, steel, and copper, which is the one that we are familiar with. Then number five, what are the materials that do not conduct electricity called? They are called insulators, right? They are called insulators, and we have examples such as wood, rubber, and plastic. So now, just take a minute quickly to copy down the corrections. Now, grade 9 learners, we're still waiting for those questions, your comments, or you can send us your work, right? Let me remind you of 079 578 2908. So now let's move on with our lesson, right? Let's talk now about the factors that affect resistance. What affects resistance, right? We have four main types of factors that affect resistance. Number one is length of a conductor, how long or short a conductor is, right? And also we have what? Temperature of a conductor, how hot or cold a conductor is. And we also have what? Thickness of a conductor, and also type of material. These are the four main factors that affect resistance: length of a conductor, temperature of a conductor, thickness of a conductor, and type of material. And I know some of you are wondering how now, right? Don't worry, we're going to discuss each and every one of them right now, right? Starting off with the first one, which is what? Length of a conductor. So the question is, how does length of a conductor affect resistance? This is how. The longer the conductor, the higher the resistance. What do I mean? The longer the conductor, the higher the resistance. Right. Here we have two conductors here, right? We have a short one, which is 1 foot long, and we have what? A longer one, which is 2 feet long. What happens here, right? And we are saying the longer the conductor and the higher the resistance, meaning the one which is 2 feet long, or the longest one, is the one that has what? Highest resistance. But how? This is because as current passes through a conductor, right, the distance in which it has to take, it is longer, right? It is longer, and along the way it comes across what? atoms, right? It bumps into atoms, and the longer the distance takes, the more the atoms it bumps onto along the way, right? So the longer the conductor, the higher the resistance. This is because it has a long way to travel through, right, to reach each and every component. Hence, the resistance becomes higher as compared to the one that is short, right? This one is just like it goes now and it gets to any component quicker, right? The following one is what? The following one is temperature of the conductor. How hot or cold the conductor is, right? So this is how. The resistance of most metal increases with increasing temperature. So meaning what? The higher the temperature, the higher the resistance. Like the one of the kettle we were talking about, right? As the kettle coil receives what? Electrical energy, right? That coil serves as resistance to oppose the electrical energy. What happens now? That energy is transferred into heat, right? And the more the coil gets hotter, what happens? The kettle at some point shuts down, right? To offer more resistance, right? So it offers resistance, and resistance increases with temperature. And also, another one is what? Another one is thickness of a conductor. This is how a thickness of a conductor affects resistance. The thinner the conductor, the higher the resistance. But how? Right? We have two wires here. One which has a diameter of 3 millimeters and the other one having a diameter of 6 millimeters. But how does it affect resistance comparing the two, right? This is how. Now imagine what? A hose pipe, right? Imagine a hose pipe. A thicker hose pipe does what? It allows more water to flow, right? Whereas a thin hose pipe allows only moderate amount of water to pass through. So the same happens here, right? The 3 millimeters wire will have more resistance as compared to the one that has 6 millimeters, right? What happens here? There is small space for the current to travel, right? It's like it's constricted. There is small space for the current to travel. Whereas in the 6 millimeters wire, there is vast amounts of space for the current to travel. It travels freely so, right? So now the thinner the conductor, the higher the resistance. So between the two, A and B, A would have what? We have more resistance compared to B. And the last one here, right? The last one is type of material. How does type of material affect resistance? This is because some metals, for example, copper, is better than conductors that are nichrome, for example, right? It is better than other metals such as nichrome. So the higher the conductivity, the lower the resistance, meaning the higher chances of it allowing electricity to pass through, the lower the resistance. Do we get each other? Right? Here's an example of copper and nichrome, right? Copper is a good conductor of electricity. It has high conductivity. So the higher the conductivity, the lower the resistance, because it allows more electricity to flow through freely as compared to nichrome, right? Nichrome has what? Has a higher resistance. So now, let's summarize what we have learned today. So today we were talking about what? Resistance. And we started off by explaining that a conductor is a substance that allows the flow of electric charge through it, right? It allows the flow of electric charge. So now, as it allows the flow of electric charge, there's resistors that resist what? Or they offer resistance. They resist the current flow, right? And resistance is the way in which a material opposes or attempts to prevent the flow of electric current through it. And we talked about what? A resistor. We said that a resistor is a component or a part in an electric circuit that does or offers resistance. It opposes the flow of current through it. And we also talked about a resistor trying to prevent the flow of electric charge, right? Now, we highlighted this word here. We said it tries, right? It tries, meaning it can be able to stop it completely or it can be able to minimize the flow of current, right? Not only that, we said that a resistor is placed in a circuit to control current, right? Or to provide useful energy transfer. And we gave you an example of a kettle coil, right? We said that a kettle coil receives electrical energy from the cord that is plugged into a wall socket, right? So from that cord, there's what? Flow of current or flow of electricity. So when it reaches that coil, the coil heats up, right? As a result, the energy is transferred from electrical energy to heat energy, and you are able to boil the water. And the more the coil gets hotter, what happens? The water reaches its boiling point and the kettle shuts down, right? We said that examples of resistors also are light bulbs, rheostats, and motors, right? Those are our examples of resistors, right? They transfer the energy into electrical energy, from electrical energy into heat, light, sound, or whatever energy, right? And also, I've put a link for you, right? Which is the one for PET simulations, right? Now let's do another example again, right? Here, we're going to get into lab when we get here, right? We get into lab, right? So this can help you to be able to construct a circuit and also test different materials for their conductivity and check how resistance works or whatever that you might be interested in when it comes to circuits, right? So here we are constructing a simple circuit which has a resistor in the form of a light bulb, right? And we have a power source, and we're going to connect another wire. Right? Then we connect another wire to the power source. Then we connect a switch, right? So that we are able to control the flow of electricity, right? So here is our circuit. It is complete, right? As you switch on, what happens now? The light bulb becomes lit, right? The light bulb becomes lit, right? As you can see now, there's the flow of current. And as the current is flowing, when it gets to the light bulb, that electrical energy is the one that is transferred into light energy and heat energy. So it resists what? The flow of current. It slows down the flow of current. Are we together? Now the current here is slowed down so that the resistor can be able to transfer this energy into the useful energy, and in this case, light energy or heat energy. Are we together? So now moving back to our lesson, right? We also talked about what? We also talked about the factors that affect resistance in a circuit, right? We talked about the first one being the length of a conductor. How did we say length of a conductor affects resistance? We said that the longer the conductor, the higher the resistance, right? So meaning what? If you have a long conductor, that conductor has what? It is long, and the current in it has to travel a long way, right? As it travels a long way, it bumps into atoms, right? As it bumps into atoms, there are many atoms along the way offering what? Resistance to the electric current, right? And also, another factor that affects resistance is the temperature of the conductor. We said that the higher the temperature, the higher the resistance. Or we said that the resistance increases with temperature. And I gave you also an example of what? Of an electric coil. We said that coil receives what? Electrical energy and transfers it into heat energy. As it heats up more and more, right? It boils the water, right? The energy is transferred into the water in the form of heat, and it boils the water. As the water boils and reaches its boiling point, at a certain time, the kettle goes off, right? And we also talked about what? Thickness of a conductor. We said that it also affects resistance. Now, I'll also give you an example of a hose pipe. Think of two hose pipes, right? A thick one and a thin one, right? A thick one allows for more water to pass through, right? It allows for more water to pass through. Whereas a thin one allows only minimal amounts of water to pass through. The same goes for a conductor, right? The same goes for a conductor. The one that is thick offers less resistance, right? Because now there's vast amount of space for the electric current to flow, right? The electric current flows freely in that wire because it is thicker. And also the thin conductor, it constricts what? The flow of current, right? So now there is less space for the current to flow. It flows in minimal amounts. So the thinner the conductor, the higher the resistance. Are we together? And we also talked about what? The type of material. And we said that materials such as copper, they offer more conductivity, right? Meaning they offer more allowance for the electricity to pass through. So as they offer more conductivity, what happens? When the conductivity is high, right, there's going to be less resistance because now there's the free movement of electrical current along that conductor, right? It allows for more electricity to pass through at a time, right? So there's going to be less resistance. But other metals such as nichrome, right, they have less conductivity. They do not conduct electricity so good. So what happens? They offer more resistance, right? So now, the lesser the conductivity, the more the resistance, right? So now, I'm going to give you 3 minutes so that you can be able to send us any WhatsApp questions or any comments. Welcome back, grade 9 learners. Now, it seems like there is no questions on our WhatsApp line, but now, for future references, right? Don't forget to send your work. We can mark your work online, and also you are able to comment on our lessons, right? So now, let's look at what is going to happen in the next lesson. In the next lesson, we're going to be talking about series circuits. So now, I want you to go home to do your homework, right? Research about series circuits, right? What I can tell you for now is that series circuit is a circuit that allows for electricity to pass through along one pathway, right? There is only one pathway in which the electricity can flow, right? And we're going to talk more about that further next week in our upcoming lesson. So from me to you now, keep on sanitizing, keep on respecting others, keep on respecting your teachers, keep on respecting yourself, and goodbye.